The F-35 stealth explained, how it's actually detected. What if I told you the most advanced stealth fighter in the world isn't actually invisible? For decades, stealth technology has been marketed as something close to magic, aircraft that simply vanish from radar screens. But the reality is far more complex, and honestly, far more interesting. Because the F-35 Lightning II isn't invisible. It's engineered to be hard to detect, not impossible to find. And today, we're breaking down exactly how it works, and more importantly, how modern systems can still detect it. But before we go deeper, if you're into real engineering, real physics, and the truth behind military technology, make sure to subscribe. Most people watching aren't subscribed, and you don't want to miss what's coming next. Let's begin. To understand how the F-35 can be detected, you first need to understand what stealth actually means. Stealth is not invisibility, it's reduction. Specifically, reduction of something called radar cross-section, or RCS. This is essentially how visible an object is to radar. A normal aircraft reflects radar waves back to the source, making it easy to track. The F-35 is designed to do the opposite. Its shape, its materials, and even its panel edges are all carefully engineered to scatter radar waves away from the source. Instead of bouncing signals back, it deflects them in different directions. That's why, from certain angles, it can appear incredibly small on radar, sometimes comparable to a bird. But here's the key point. That only works under specific conditions. Because radar is not just one system. There are many types of radar, and some of them are much better at detecting stealth aircraft than others. Let's talk about the first major weakness: low-frequency radar. Most stealth aircraft, including the F-35, are optimized to evade high-frequency radar, the kind used in fire control systems. But low-frequency radar operates differently. It uses longer wavelengths, and those wavelengths interact with the aircraft in a way that makes stealth shaping less effective. Instead of being scattered cleanly, the waves can resonate with the structure of the aircraft, which means detection becomes possible. Now, this doesn't mean low-frequency radar can lock on and guide a missile easily, but it can detect something is there, and that's all you need to start tracking. Now let's move to another factor: infrared detection. Even if radar struggles, physics still applies. The F-35 generates heat from its engine, from air friction, and from internal systems. This heat creates an infrared signature. Modern infrared search and track systems, known as IRST, are designed specifically to detect this. And unlike radar, they don't emit anything, which means they're passive, silent, undetectable. So even if an aircraft avoids radar, it can still be seen through its heat signature, especially at long distances and high altitudes. But it gets even more interesting, because detection isn't just about one system anymore. Modern defense networks combine multiple sensors: radar, infrared, electronic intelligence, even data from satellites. This is called sensor fusion. Instead of relying on one method, they combine everything. So even if the F-35 reduces its radar signature, another system might still pick up something. And when all that data is combined, a picture starts to form. Not perfect, but enough. Now let's talk about something most people don't consider: angle. Stealth is highly dependent on geometry. The F-35 is optimized for frontal stealth, meaning it's hardest to detect from the front. But from the sides or rear, its radar signature increases. This is especially true when the aircraft is maneuvering, because as it turns, different surfaces reflect radar differently, which creates moments of increased visibility. Short windows, but enough for advanced systems to exploit. There's also the issue of external factors: weather, atmospheric conditions, electronic interference. All of these can affect how radar waves behave, sometimes helping detection, sometimes reducing it. But the key takeaway is this: stealth is not a constant. It changes depending on the environment. And then there's one of the biggest misconceptions of all. People think stealth makes an aircraft untouchable. But in reality, stealth is just one layer of survivability. The F-35 also relies on electronic warfare systems, advanced sensors, situational awareness, and networked data. It's not about being invisible, it's about being harder to target and faster to react. So can the F-35 be detected? Yes. Under the right conditions, with the right systems, it absolutely can. But detection doesn't equal destruction. Finding something is one thing. Tracking it precisely and engaging it effectively is something else entirely. And that's where the F-35 still has a massive advantage. But here's the bigger picture. Modern warfare is evolving. It's no longer about single systems. It's about networks, data, integration, and adaptation. Stealth is still powerful, but it's no longer unbeatable. And this is just the beginning, because new technologies are already changing the game. Quantum radar, AI-assisted tracking, next-generation sensors. The future of detection is evolving just as fast as stealth itself. If you've made it this far, you're already ahead of most people watching. So here's the question. Is stealth still worth it? Or is it becoming obsolete? Let me know what you think. And if you want to see how infrared systems specifically track stealth aircraft, or how modern radar networks actually work in real scenarios, make sure you subscribe, because the next video is going even deeper. And trust me, you don't want to miss it.